So I want to create a Gaussian splat out of this simulation that I have here in Houdini. So if I press play here, this is just a play blast or a flipbook, as we call it in Houdini. And this is not the render. So obviously the shaders are just some kind of a quick preview, and the spheres or the balls, they just have like some flat colors. So this is not a high quality render. It would look better, obviously, if it was a high quality render with proper materials and everything, but I just don't want to wait for renders, so I'm just doing flipbooks. So you can imagine that this is a render instead of a flipbook. But the plan is to create a Gaussian splat animation out of this. So we would get something similar to this, or very, very close to this, for as a Gaussian splatting, but containing the simulation as well, right? So what we need to do here is training a Gaussian splat for every frame of the simulation, and then just put together a sequence of Gaussian splats in order to get a full representation of the simulation. So if I go to Houdini, what I've done here is I'm using GSOPs in order to automate this a little bit. But essentially what I have is this sphere that is surrounding my my simulation, right? So this is kind of like a sphere that is covering pretty much every single angle of this thing that I'm using here for simulating. Obviously, it's going to be a little bit tricky because a lot of these angles are actually occluded, meaning that, you know, whatever is happening inside of here is going to be very hard to capture. But aside from those occluded areas, I think I'm pretty sure that I can cover the entire thing. So anyway, I'm using this sphere just to populate the scene with cameras. So at the end of the day, these are the cameras that I'm creating, and I can very quickly, you know, decrease or increase the subdivisions of the sphere to get more or less cameras. So I can just reduce this to 10 and 10 samples, and now I get less cameras, right? Or the other way around, I can go for 20 and 20 and get even more cameras. In this case, I'm not particularly worried about the amount of cameras that I'm using because, again, I'm doing flipbooks. Some flipbooks are very quick to render. If I was doing like ray trace renders, I would probably go for less cameras, but again, because render times are tiny when it comes to flipbooks, I don't care that much. So I'm gonna go with this amount of cameras, and this will give me like 165 cameras. Cool. So then, as I said before, I'm using GSOPs in order to automate this. So this will essentially create an animated camera out of all of these cameras that I have here. So if I look through my render camera, these are all the angles that I'm going to render. Okay, and I need to do this for every single frame, right? So as you can see, my animation or my simulation is not really doing anything, right? It is fixed to the very first frame, and that is because I'm using a time shift node at the beginning. So basically, I'm holding the animation at frame 1, and I can change this at any time to actually play the animation. So I will use this time shift in order to automate the Gaussian splatting rendering. Okay, cool. So yeah, and then I'm using again this GSOPs node, the training data node, that is essentially using this directory to write the data for every single frame. So I'm basically pointing to my job path, and then I'm using a channel reference for my time shift node and the frame parameter, meaning that when I change this time shift frame parameter, it is going to update the file name where I'm writing the files. And that's pretty much it, right? So the only thing that I have to do here is click on Save Training Data, and this is going to export the camera information and the sparse point cloud. The sparse point cloud is essentially this, and this is something that you need to do every time that you are generating synthetic data for Gaussian splatting training, because this is not a real world object. And that's pretty much it. Once the data has been exported, the other thing that we need to do is to render the flipbook, and that is this button over here, render flipbook. I'm going to render PNG files, so click on render flipbook, and this is going to render all of those 165 cameras I believe I had. And again, this is a flipbook, so it's very, very fast to render. Even though it has a little bit of shading and a little bit of lighting and shadows. They are not perfect by any means, again, because it's a flipbook, but it would be exactly the same if I was doing a render. So I usually do flipbooks, and if that works well, then I can spend the time doing the renders. Okay, cool. So this is done. So the data has been saved in my Houdini project. It creates a folder that is called gsplat training camera 1, and if I go inside, we have the images. So these would be all the frames that I'm going to be using for training, and this is the point cloud and the camera position, right? So if I take that into Postshot, I can just drag and drop the folder over here. I'm going to use all my cameras. The camera poses, this is set to import because we created the camera poses in Houdini, and then I can use the amount of training steps that I want to use. I'm going to set this one to 15, even though it's not like super high quality, but I don't want to spend a lot of time because this is just a test. And if it works, then I will do like a proper render, import, and the training has started. So let me hide the camera, let me hide the point cloud, and this is the Gaussian splat being trained. So as you can see here, I'm almost at 4,000 steps out of 15,000, and this is looking pretty cool already, even though it's not even halfway through the training. And this looks quite nice. Obviously, again, some of the very occluded areas are going to be very hard to capture. So something like inside of this thing is not going to look perfect. Again, we're still halfway through training, but it's going to be very hard to capture that. But maybe we don't even care, right? Let's say if we look at the whole thing, something like that, it looks pretty sharp to me. It looks pretty good. So I'm going to wait for training, and then I can carry on. So the training has finished, and this looks pretty good to me. Again, some of the shadows are not great, and that is because the origin point wasn't actually any good, right? Could be better if this was a render, but anyway, I think I can live with this. Okay, cool. So I don't need to use Postshot anymore, at least not for now, because obviously I need to repeat this process for every single frame. So I need to render flipbooks for every single frame, and I have like 240 frames. So for every frame, I need to render this camera array, and then I need to do the training in Postshot for every single frame out of those 240. So I need to batch those two processes, the rendering part in Houdini and the training part in Postshot. And the way to do that, I guess, well, there are probably many ways, but one way that I figured out, because obviously the batching process needs to do the following, right? It needs to change the time shift from frame 1 to frame 2, and then frame 3 and 4 and so on. And then it needs to go through the GSOP's training exported, and it needs to create the it needs to save the training data, and it needs to render the flipbook. So I just created this simple script over here. So these scripts expects the object where all of this is stored, and all of this is stored in this geometry node over here. So essentially, I just need to point to that, and that would be obj geo time shift 1. That is the name of the node where we need to change the frame, and then obj geo Gaussian splat generate training data 1. This is this node, and it needs to click on save training data and render flipbook. So that's pretty much everything that we need to change here. There is one last thing, and is the start frame and end frame. So I'm going to start at frame 1 and I'm going to finish at frame 240. So I can just copy all of that. I can go to window, Python shell, and I can just paste my script there, saving training data, and this is going to go through every single frame automatically. So if I check my folder, well, I should have started the frame 2 because I have done already frame 1. But anyway, let's wait a couple of seconds, and this will be finished very, very soon. I think I went a little bit overboard in this specific case with the amount of cameras. I think 165 is probably just too much. But again, because flipbooks are quick anyway, I didn't care that much. I would probably reduce it by half or so for the final render, but let's see. But as you can see now, we have camera 2, and it's rendering the second frame. So this is going to take a while to go through all 240 frames. Once that is finished, we can take a look and see how we can batch process the training in Postshot. So the process has finished. As you can see here, it has finished processing all the frames. So we're ready to go. Just to double check, if I go to this folder, I have all the 240 frames. And if I go inside of any of these folders, I would have my images and my sparse point cloud data and the camera position data. Then to do the batch processing in Postshot, you can use the command line interface, which, you know, is not very comfortable to use, but I guess any advanced user know how to use it. But to simplify things a little bit, I built this simple user interface here that is pointing to the command line interface, which is, this is the default installation for Postshot. But if you have installed it in a different location, you can change it here and just point to this executable file. Then I need an input for my training data, which is this folder, right? So I can just go inside, select that folder, and it's going to run this program over every single file that we have here. And then we need an output folder. So I'm just going to create a new folder here that I'm going to call Postshot out or something like that. And now I can choose that one here, Postshot out. And that's pretty much everything that we need to do here. We need to select the training profile, and obviously in Postshot you can use different training profiles. You can use splat 3, you can use splat MCMC or the splat ADC. Those are the ones available for Postshot. For most of my training I use splat 3, but again, if I wanted to use a different one, I just need to type it here. This is the amount of steps that we want to use for training. I'm going to use 15, but you can use more or less. And finally, the max image size. So if this one is set to 0, it's going to use the full resolution of the training data. If you want to use a specific resolution, you can just type here something like 1000, and then it will use 1000 pixels, or in wide, or 512, or 4096 or whatever it is. For most things, I tend to use full resolution, so I just leave it at 0. I only downscale images when I'm using thousands of images, which is not the case. Here we're using 165 images per frame, so I'm gonna stick to full resolution. And finally, I can choose here to export a post-shot scene, and this one will contain the train Gaussian splatting, the cameras that I use for training, the images, and the sparse point cloud. And I can also export a PLY file, which would be the final splat. That's it. So I just click on start process. The batch processing started. This might take a while. Of course, it's going to take a while. It's launching the console, and this will be ready when the whole 240 frames have been trained. So the first frame has been trained already, and as you can see, it has exported the PLY file and the post-shot scene. So we can just double click in the post-shot scene to see how it looks. And as you can see, everything looks as expected, right? So this is the final Gaussian splat. If I hide the cameras and the sparse point cloud, this is how it looks. And yeah, it seems to look okay. So I'm gonna close Postshot, and I'm gonna let the software go through every single frame. There is a log here that is saying that the training is complete. It has exported the PLY file, etc., and it's just jumping to the next frame. So all the frames that make the Gaussian splat simulation have finished training. So I have all these 440 frames over here. So I'm gonna import them in Postshot and see how it looks. So I'm just gonna import, select all my sequence of PLY files. So that's all the way up to 240. Open. And here it is. Okay, let's take a look. Let's press play. And there you go. Here we have a Gaussian splat made out of Houdini DOP simulation. As you can see, the shadows are a little bit flickery, or a lot. And that is a combination of low resolution renders. I mean, these are, well, they are not necessarily very low. They are like 1K resolution, but they could be better. And obviously I'm training these at 15,000 steps. I could go higher. So yeah, this is a little bit flickery depending on the camera angle. But just as an exercise to showcase how to train animations to create Gaussian splats, I think it showcases what I was meant to explain here. And obviously this is all real time, so you can run this in your phone or in a game engine, or you can take it back to Houdini and just use it in a 3D scene, but in this case as a Gaussian splat, not as a geometry anymore. Okay, so yeah, that's pretty nice, right? And obviously this is a very silly use case for this workflow, but hopefully you can think of many really useful solutions for this. I mean, I can think of so many different things that I could use this for. But the most important thing, and I was actually surprised, is that the quality of the geometry is actually, well, the geometry. I mean, the geometry representation in this Gaussian splat is pretty good, I think. Like all the edges are quite sharp and detailed, and I don't really have any artifacts aside from the shadows, right? So this is pretty cool. Also, and I wasn't expecting this, the marbles here, they are perfectly animated through the whole sequence. So they are perfectly captured as a Gaussian splat. Even though they are not that big, meaning that there are only a bunch of pixels. Well, not a bunch, but just a small amount of pixels in every frame. In some of the frames, they are not even visible, but they are still very well captured. So I'm very surprised with that. Cool. All right, so now if I go back to Houdini, this is my original geometry, right? That obviously looks perfect. Let's see how this compares with the actual Gaussian splat. So if I hide the geometry and I showcase the Gaussian splat, this is just using Gaussian splat import and a Gaussian splat source. And if I remove the lighting in the viewport and I set the viewport to raw, this is how it looks, right? Houdini is not able to play the Gaussian splat as fast as Postshot in this case, but I can just do a flipbook and it will be pretty fast. But yeah, this looks pretty good, right? For a Gaussian splat. Yeah, and obviously being a Gaussian splat, I can always go to my point cloud and modify this in any way that I want, right? So let me just for now set this one to points, and let's get rid of most of it so I can still render this as a Gaussian splat, right? So yeah, everything kind of worked. So I'm able to have an animation represented as a sequence of Gaussian splats and automate the whole batch process for rendering and training both in Houdini and Postshot.